All right, good afternoon. We are working on our geometry test review, Unit 8. All right, so I'm going to try to hit a couple of concepts throughout this video to hopefully touch base with everything you have a question on before our test the next time I see you. All right, so we'll go with the first 5 questions up here. We'll look at them and we'll see what everything means. So number 1 is name an angle complementary to angle GHF. So let's look at angle GHF. Angle GHF is here. So we know that complementary is when 2 angles must add up to be 90 degrees. Well, this mark here, if I switch, this mark here shows us or alerts us that that is a 90-degree angle. Now, if this angle here is 90-degree angle, we also know that this angle here is going to be 90 degrees. So that helps us because we know that the angle GHF is going to be complementary with angle AHG because these 2 angles add up to be 90 degrees. So my answer here will be angle AHG. And yes, I did change a couple of these questions. I know this looks like your homework and some of the questions are the same, but I did change a couple. So make sure you're paying attention as you do your homework. All right, vertical angle. Remember, vertical angles are angles that go through the vertex, right? So if we're looking for angle DHF, DHF is going to be here. I'll use red for that one. DHF, DHF. We're going to go through the vertex and we'll end up over here. So we'll be at AHB. Angle AHB. All right, name an angle supplementary to BCH. BCH. Okay, so BCH, if I can switch up, I haven't. BCH is here. Did I do BCH? BCH, that should have been BHC. Somehow that's off. Should have been BHC. And to make that complementary, we're going to go ahead and pair that with FHC. And as you guys can see, that makes a complete half circle. Remember, half circles, right? 180 degrees. And that creates a straight line through here, BHF. And then that helps us to create the supplementary angle, which equals 180 degrees. So one thing that you notice when we use our complementary and supplementary angles, I used a piece of the angle that was provided, right? So when we looked at GHF, I used HG in my second angle. When I used BHC, what did we use? I used FHC. So one thing that can help you out is always to try to use one ray of the angle that's provided. Name an angle adjacent to AHG. Adjacent, remember that means they are next door neighbors and they're going to have one ray and one vertex. So AHG here, AHG is going to be adjacent with, let's go on the other side and go with AHB. You see how we use the same ray there and it hit the vertex. All right, name 2 lines that are perpendicular. Remember, perpendicular lines are straight lines that bisect each other and create a 90-degree angle. So therefore that, let's erase some of these. Let's erase some of these. You guys can always rewind if you want to go back and go through that again. So the 2 lines are going to be AHD and, let's use green, BHF. And we know that they create a 90-degree angle because they show us right here, 90 degrees. All right, let's move on a little bit, scroll down. All right, here is something that we went over in class today. You guys kind of have a good idea about this. Let's see if we can finish up the concept and make sure we can drive it home. So we're going to be measuring angles that do not begin on 0. That do not begin on 0, right? So let's look at KAD. KAD. D. My freehand is a little off, but you guys get the picture. When you have angles that do not begin on the 0, right? F or B. F and B, right here and here, begin on 0 or 180. When you have angles like that, you look at the outer ray, D and K, and you simply count what's in between. That will give you your measure. So if I started at 70, I'll go 10, 20, 30, 40, 50, 60, 70, 80, 90 degrees. So angle KAD is 90 degrees. And yes, 90 degrees are right angles. Okay, let's look at another one. Let's try EAD. So E starts here, and we go to A, and then we go to D. So this one's a little smaller, right? Let's say we start at E, and we go 10 to 140, 20 to 150, and that's going to be 30 degrees. Angles less than 30 degrees are acute. You got it. All right, now the next one is going to be angles NAK. So let's start there. Let's do, we haven't done green yet. So NAK. So no one that's a little smaller than 90. And if we look at that very quickly, that's going to be 20 degrees. That's also going to be acute. All right, let's look at one that's, can we get one that's more than 90? No, we cannot. Well, one that is more than 90 would be F, right? A, D. I know that's not up there. I just made this up, but that would be 160. Remember, you start where the ray goes towards 0, and then you count from there. So then you would count 10, 20, right? Go all the way around. You get to 90. You keep going, and then you would stop here at 160. All right, let's keep going. Complement, right? If you want to find the complement to an angle, it's just saying the angle, right, plus 29 would equal 90 degrees, because remember, complementary angles add up to be 90. And then the same for supplementary. N plus 65 would equal 180. You guys can do that work. Now it's just a one-step equation. I have faith in you to be able to do that. All right, now more angles. This time we have to figure out the exact number of the angles. So read it here. This is one that I changed a little bit. We know that, right? We know that the angle A, B, and CD, or the lines A, B, and CD, are going to be perpendicular. Remember, we just said when perpendicular lines intersect, they create 90 degrees, and they have shown us here that angle 6 is equivalent to a 90-degree measurement. We know that angle 2 is going to be worth 60 degrees, so I'm just going to drop a 60 in here to help me. It looks like 260, right? I'll erase that so we can understand that. We'll put 60 here. Oh, put that down. 60 degrees right there. All right, now what is angle 5? Well, angle 5 is our vertex. All right, angle 5 is our vertical angle because it goes through the vertex. So what do we know about vertical angles? We know that they are congruent. Congruent angles equal one another. So if angle 2 is 60, angle 5 is 60 degrees. All right, now we have measure of angle 1. Well, how can we find angle 1? Well, we know that angle 6 is 90 degrees, so that means this side here must also equal 90. So therefore, angle 2, right, if I put measure of angle 2 plus angle 1 will equal 90. Then I just sub in, angle 2 is 60, plus angle 1 is not equals 90. Then I go ahead and subtract, and I have angle 1 is equal to 30 degrees. All right, now we're looking at angle 3. Well, angle 3 is vertical to angle 6, so we know that's 90, right? Not only is angle 3 vertical to angle 6, it is also supplementary to this angle here. We know this is 90, and we know that when we add these two together, they're going to equal, right, 180. If I add all of this together, it's going to equal 180, so 90 plus 90 must be 180. Name a set of complementary angles. you could say angle 4 and angle 5 are complementary. All right, now we're done with our angles. We're going to scroll down, and this is our Pythagorean theorem section of the homework. So here you're just going to use a squared plus b squared equals c squared. The most important part of this is figuring out what your c is. This cannot be interchanged with any other number. C always represents your hypotenuse. Your hypotenuse is the leg or the side of the angle that is opposite the right angle. So here it's always the longest, right? And it's always opposite your 90 degree marker, okay? So we have 6.2, we're gonna drop that in for A, 6.2 squared, and we also have 7.5 squared. And then we'll go ahead and do some nifty math. 6.2 squared is 3844. And that's going to be equal to, we got to add our b squared, and 7.5 squared. And that's 56.25, right? Then you're going to subtract 38 from each side. And that's going to give you 17.81. Now, we are not done because we have only found b squared, but we want b, so we will square each side, and we will see that b is equal to 4.22 because they want to round to the nearest hundred, and that is your nearest hundredth. All right, the last concept we have to work on here is to prove if this is a right triangle. I may not go through all the work. We'll see. I know that we have to use a squared plus b squared equals c squared, but how do we know if it's a right triangle? Well, these must prove to be true by putting the numbers in the correct place and making sure that this side equals this side. Well, what number is going to be our c? 7, 24, 25. 25 is going to be our c because it's the biggest number. So we'll use 7 here, and we'll use 24 here. What is 24 squared? 24 squared is 576. What is 7 squared? Well, 7 squared I believe is 49. I can do a little bit of math. And 25 squared is 625. So let's add these two together. Is 49 added to 576. Is that 625? Why, yes it is. So now 625 equals 625. So yes, this is a right triangle. All right, let's move on to our next one. Okay, now we're going to use, find the missing side. This is just like the one we were doing with our pictures. They don't give us the c squared here, so we're going to have to find that. That's pretty easy. And they give us a leg here. They give us the hypotenuse here, right? And we are missing a leg, right? So we would just set that up. I hope you guys can see that that's supposed to be a G, right? So it would be a squared plus 8 squared equals 17 squared. And over here it would be 24 squared plus 12 squared equals c squared. All right, down here, the biggest thing you have to understand is that these are rectangulars. So what does that mean? That means that the opposite sides are equal. So that means that if this side is 5, this side is 5, right? And that if this side is 7, that this side is 7. You guys should be able to work from there. Same thing goes here. If this side is 12, this side must be 12, and they're going to equal one another. And if this side is 8, then this side is 8. So you guys should be able to work through that. And here, these are vertical angles. So if we work through vertical angles, remember what that means now. Vertical angles are angles that equal one another. So you have 12x, right, minus 3 is equal to 10x plus 15. All right, now you would solve that, right, using DCVS, right? So you would minus 10 from each side, and you have 2x minus 3 is equal to 15. You would add 3 to each side. You get 18 is equal to 2x. Divide by 2, x is equal to 9. All right, so there you have that, okay? And that's our last one. Why does this work? Because if this is angle A and this is angle B, we know that angle A is equal to angle B because they are congruent angles. Okay, and last one. Oh, last thing we'll do here is our 3D shapes. So remember, 3D shapes, it's always important to figure out where you're looking from. I always like to draw a little stick figure who's kind of happy, right? He's looking here. This is what he sees going there. So if he's looking from left to right, he sees 1, 2, 3 blocks. I'll make that a 2. Make that a 3. 3 blocks, right? So we'll just color in up here. If he's looking from left to right, that's his first column. His second column, he'd see 1, 2. Oh, okay. It's starting. I can see how that looks. And we see 1 here and 1 here, and that goes there. Now, I'm going to leave the right for you guys to do on your own. I will go over the top. The top is looking down, right? The top is looking down. So you could just drop a T in there for every place that you would look at the top of the block. That's one way to do it. And what would you see? You would see everything here and everything here. All right. Like I said, I was going to leave this for you to do on your own. Just make sure you guys know that your guy is going to be standing here when he looks at the right, and this is what he's going to be looking at. All right, remember, we're taking a 3D image and we're turning it into a 2D representation. Okay, that's the end. I hope it helped. If we don't have school tomorrow, make sure you study. If we have a little bit of snow, enjoy the snow. Come prepared to take the test before spring break. You do not want to take the test after spring break. Okay, you guys, have a good one. Bye.